When solving a system of linear equations in 3 variables, you need to do the following. Step 1. Select 2 of the equations and eliminate one of the variables from one of the equations. 2. Select any 2 of the other equations and eliminate the same variable from one of those equations. You will now have 2 equations that have 2 unknowns. Step 3. Eliminate a second variable from the 2 linear equations in 2 variables and solve for the remaining variable. So this will be the time where you get one of the letters or one of the variables equaling something. Step 4. Use the value from the variable from step 3, found in step 3 to find the value of a second variable. And now that you have 2 variables known, use those 2 values identified from steps 3 and 4 to find the value of the third variable. Again, optional. Check to see if your answer is correct by just plugging them in and seeing if it works. But again, it's not necessary. So it's a lot of steps and it seems kind of confusing. So let's break it down in an example. So we have this system of 3 linear equations and 3 unknowns. And what we're going to do is we're going to solve for, or we're going to pick out 2 equations to solve or get rid of one of the variables. So first thing I'm going to do is I'm going to take the first equation, x minus 3y plus z equals 13. And then I'm going to take the second equation. So 3x plus y minus 4z equals 13. And I'm going to get rid of one of the variables. I'm going to get rid of x. So what am I going to do? I'm going to multiply the top equation by a negative 3. And I'm going to leave the bottom equation as is. So, I'm going to get negative 3x plus 9y minus 3z equals negative 39. And then 3x plus y minus 4z equals 13. And now I will add all the common or all the like terms together. So the x's cancel. I get 10y, I get negative 7z, and then I get negative 26. So this is my first equation after I eliminated x. So now step 2, I'm going to pick 2 different ones. I am again going to choose the first one, x minus 3y plus z equals 13. And I'm going to choose the third one. So 4x minus 4y plus 2z equals 0. And I again need to get rid of one of the variables. But because I chose x originally in the first step, I'm going to choose x again. And so I'm going to multiply it by 4. So I'm going to keep the bottom equation as is. So I'm going to get 4x minus 12y plus 4z equals 52. And the bottom equation stays as is. Minus 4y plus 2z equals 0. And now I'm going to add all the common terms. So the x's again cancel out. I get negative 16y plus 6z equals 52. And now I have 2 equations. So now I'm on to step 3. So write them all over here. So 10y minus 7z equals negative 26. And negative 16y plus 6z equals 52. Now I'm going to need to get rid of one of these variables. So whether it's y or z doesn't matter. I'm going to get rid of the z's because they're smaller numbers. So I'll multiply the top equation by positive 6. And I'm going to multiply the bottom equation by positive 7. So distribute the 6 across, distribute the 7 across, and I'm going to get 60y minus 42z equals negative 156. So separate that so it'll confuse them. And then the 7 across is going to give me negative 112y plus 42z equals 364. Very nice. So now, combine like terms. Combine the y's. I'm going to get negative 52y. The z's cancel out as necessary. And then the negative 156 and the 364 is going to give me 208. So now solve for y, divide by negative 52 on both sides. And y is going to give me negative 4. So I now have one of the variables solved for. So step 4, I'm going to plug this back into one of the original two here to solve for z. And I'm probably going to do the one with the smaller numbers. So I'm going to get 10 times negative 4 minus 7z equals negative 26, which is going to give me negative 40 minus 7z equals negative 26. I'm going to add the 40 over, so negative 7z equals 14, and then divide by negative 7, z is going to give me negative 2. So just box those in just so I don't lose them. So I now know what y is, I know what z is, and now finally for step 5, I'm going to plug both of these into one of the original 3 equations here, and I'm going to choose this one because I think it's just easier. So I'm going to plug in my y and z in there and solve for x. So x minus 3 times negative 4 plus negative 2 equals 13. So x plus 12 minus 2 equals 13. X plus 10 equals 13. And then subtract the 10 over. X equals 3. So I now have all 3 of my answers for x, y, and z. And so my solution, and I'll write it in here, is going to be 3, comma, negative 4, comma, negative 2. So that is how you would solve a system of three linear equations with 3 unknowns. It's a bit of a process, but take your time, step by step, and you will eventually get there.